Okay, it looks like it's about half past the hour, and I'm going to get started here. This is Doug Grant in Vermont, and this is my presentation in context with Al Gore's 24 Hours of Climate Reality, Countdown to the Future. And I hope to do this in about a half an hour. It's being recorded, and I will post it so people can see it later if you're not on right now. What I'm going to do is start with Al Gore's latest slide deck, which he presented at the global training and also in previous trainings, which is called Climate in 10. It's basically a 10-minute presentation. He does it in about 12 minutes. It has 99 slides. So I'm not going to give his whole presentation, but what I will do is start with my normal presentation, which has been in the past, most recently in the last half a dozen years, called Climate, What's Love Got to Do with It? And in the last 2 years or so, I've learned some things that have caused me to modify that, and I made some modifications. So now it's going to be called Climate, What's Ice Got to Do with It? The conventional wisdom is that we need to just simply reduce emissions as well as some drawdown using soil restoration and forest and agricultural soil management, planting trees, a trillion trees and this sort of thing. But it's really more than that, which we need to do to, well, I'll get into this as we talk along. So I'm going to open this up with Al Gore's standard presentation. And let me share the screen here. Where's the button? There we go, share screen. Here we go. Got to click all the right buttons. So this is my version of his presentation. And it opens with an introduction from Mr. Gore.
Hello, everyone. I'm Al Gore, and I want to thank you for joining us today for 24 Hours of Reality, Countdown to the Future. As all of you know, we're living through truly extraordinary times, and if you're like most people, you look at these challenges that we're facing now, the climate crisis getting worse, COVID-19 pandemic, structural and institutional racism, the challenges to the operations of democracy, and you ask yourself, what can we do? How do we overcome these truly existential threats that are connected? And how do we build together the sustainable future and the just and fair future that we want and deserve? Well, the presentation you're about to hear and the discussion you're about to join is about these questions. Your host is an incredible climate reality leader that I personally have worked with. And through their presentation, you'll learn the science behind the climate crisis and why it is having such a devastating impact on the ecological balance of our planet. You'll also learn how the climate crisis is connected to the COVID-19 pandemic and is connected to the broader injustices and inequities, not only in the US where I'm located, but in places all around the planet. Just as important, you'll learn that we have the solutions, and you'll learn how we can work together to solve these crises, starting with a green recovery and with a just transition to clean energy and the technologies that can make our world better in every way. You'll learn what you personally can do to make a difference and to help us create the future that we want and that humanity deserves. So before I hand you back to your host, I want to say one other thing. Thank you for being a part of this global conversation. The truth of our circumstances is very clear. We have to solve the climate crisis, and we have the solutions we need today. I know that we can solve the climate crisis. We have the political will. You know it's a renewable resource, but it's really because of people like you who are ready to commit the time and energy and attention and stand up and fight for a better world. Because of you, I know that we will succeed. Thank you.
So that's Al Gore's introduction of me. And just as information, I was trained by Al Gore in the second week of January 2007. I heard his original slideshow, 35 millimeter slideshow on KQED, National Public Radio, San Francisco, at 2 o'clock in the morning on December 22nd, 2004. And that's when I had my wake up call. I won't get into the long details of that, but I spent the next month, the month of January 2005, trying to track him down. I got very, very, very close. I like to think that I maybe planted a seed because a year and a half later, when the movie came out, An Inconvenient Truth, he offered to train 1,000 people on a moveon.org Sunday afternoon webinar. So I signed up for that and I got trained. So anyway, let's get on with the show here. This is his 44th presentation of actually the global training that happened back in July and August. And it's Truth in 10. I got it wrong earlier. So this is how he normally starts his presentation. And if you've seen An Inconvenient Truth, you will recognize that and you will understand it. But basically, he's taking a global view, an all-encompassing view of the world, which basically changed, it was a paradigm shift in the way humans perceive the world. His questions now are, must we change? Can we change? And will we change? And he talks about each of those in 3 different segments. I'm going to spend a little bit of time on the first segment, and I'll incorporate the other 2 into my own version of my previous presentation called Climate, What's Love Got to Do with It? So, must we change? We get into the science. He talks about the atmosphere being a very thin layer. We're just dumping all of our CO2 into that layer. What's happening is the atmosphere is warming up because the sunlight that normally comes through the atmosphere and the normal concentration of CO2, which makes it basically a Goldilocks climate, not too hot, not too cold, allows the Earth to maintain a constant temperature. But the problem is, and what happens is that atmosphere is absorbing some of the CO2, absorbing some of the infrared that wants to go back into space, and that's what keeps us warm. So these I don't want to spend a lot of time on because you're probably familiar with that. But the iconic photograph is a Getty image, and this is not what CO2 looks like. CO2 is basically invisible. This is steam. So it's kind of misleading. But the point is we're dumping a lot of CO2 into the atmosphere, and it's basically thickened up the blanket that's keeping us warm, and we're increasing our temperature. So now I'm going to jump out of his presentation and make a commentary on my own here, which this is the Keeling Curve, which is the CO2 concentration from about 1957 to present. And we're up around 420. The last 10,000 years during which humanity and civilization has evolved, the temperature has been around 280 to 300. In 1957, when David Keeling started measuring, it was just around 300, about 310 according to this. But I don't want to get into the science and the details. I want to stay at a higher level. Now, if you imagine what's been happening is that CO2 that we've been putting into the air has been filling the atmosphere. It's like a bathtub. We're filling the atmosphere with our CO2 emissions. Some of them are being removed by trees and other natural sinks that absorb the CO2. The ocean takes up a lot of the CO2. The land, the soil, and the trees, the biosphere takes up a lot of the CO2. But a lot of it, about 50% of it, I think is the number, stays in the atmosphere, and that's what causes the warming. And everybody should be pretty familiar with that. So what's happened over the last 200 years since we started burning oil and coal, especially in the last several decades, is that level in the bathtub has risen to the point it's overflowing, which is causing the weather, extreme weather, and the droughts, and the hurricanes, and heat waves, and everything else that's going on, fires. So now let's jump out of this. So my point of this is that we must now start to remove the CO2 that's in the bathtub to bring it down to a level that's consistent with the way we've evolved over the last 200 years. Pardon me, over the last 10,000 years. So we need to make up for the 200 years of dumping CO2 into the atmosphere. That means we also have to bring it out of the ocean, because the ocean has a lot of inertia, and as we draw down from the CO2 from the atmosphere, CO2 will come out of the ocean. So there's a big task that we have at hand. We can't just reduce emissions. We can't just slow down the rate that we're filling the atmosphere with CO2. So the question is that I don't think many people are asking, but a friend of mine, Peter Fikowski, has asked, and I caught on to this in the last couple of years, do we want to give our progeny the climate we now have, or as it worsens, what's going to happen as we go toward 1.5 degrees C, 2 degrees C? Or do we prefer to give them a restored climate down to 300 parts per million, 1 degree C, or 280.5 degrees C over pre-industrial? To do that, we need to draw down from the bathtub. We need to take the atmospheric CO2 out of the atmosphere and put it back into the ground. And we'll get into that later. So now let's jump over to my presentation, which has been in the past called Climate, What's Love Got to Do with It? I'd like to start with this quotation by Raymond Williams: to be truly radical is to make hope possible rather than despair convincing. When I heard Amory Lovins say that on a Friday night in December 2004, as a matter of fact, no, 2006, it was a week before I got trained. I wonder, what does Amory Lovins mean by that? So I use this when I'm talking to kids to ask them if they can write that in a very simple three-word sentence. Uh-oh, we got a little bit of, so make hope possible. It's a little bit out of alignment there. Make hope possible. To be truly radical is to make hope possible. I'm not about convincing people about climate change. The other interesting thing about this is Charlie Sullivan, age 12 in the UK, won the United Nations art contest for this drawing, which I think is amazing. So we're going to make hope possible. And as I said, this is my old presentation, but those are my grandkids. They're now 19 and 21. So I'd like to start with the image of the Earth, which Al Gore does. And there we are in Vermont. That's where I am anyway. I don't know where you are. You might be in California or Texas or Canada or some other place. But this is a view from the Earth, from the moon. That's where we are. Now, this shows that tiny layer of atmosphere, that thin layer of atmosphere. It's as thin as the skin on an apple or less. In this presentation, I'm going to talk about, or have historically talked about, the sun, because that's something that the Earth and the moon have in common. I usually ask that as a question. What do the Earth and the moon have in common? Sun. What don't they have in common? Wind and water. The moon doesn't have wind and water. It's a rhetorical question to get kids to start thinking a little bit, maybe adults too. So the presentation is mostly about wind and water and ice and oil. Now, it's not what ice and oil have in common. Pardon me, it's not what Earth and moon have in common with oil and ice, which obviously the moon doesn't have any. It's what do oil and ice, a rhetorical question, what do oil and ice have in common? And the answer is, and it's explained later in the presentation, if it weren't for oil, we wouldn't have ice. As the carbon dioxide in the atmosphere was converted over millions and millions and millions of years into organic material and sequestered into the earth and became oil, that lowered the temperature to a point where ice was formed about 50 million years ago for the first time. Out of 4.5 billion years of Earth's existence, 50 million years ago, ice formed on the planet because of the CO2 that became oil as organic material. So this is what the Earth really looks like. Pardon me, the sun. That's really the sun. That's the size of the sun. No, I'm sorry. I haven't done this presentation for a while. That dot up there is the Earth relative to the sun. Excuse me for that. All you kids in the audience probably caught that right away. So I like to show these images because they show the size of the Earth relative to the very large planets, which cause Milankovitch cycles, and that is the rotation of the Earth, the orbit of the Earth around the sun is like an ellipse, and it's caused by the gravitational pull of Jupiter and Saturn. That's what we'd look like if we were a moon on Saturn. We're obviously saturated in oil, and we're going to talk about ice. This program is about ice. This is the North Pole, or at least that's where the North Pole was. Andy Revkin wrote a book called The North Pole Was Here. And if you were to put a stake in the ice, within a day, it would be a quarter mile away. The ice is constantly moving, but it's a good image to remember what the ice looks like at the North Pole. From 2007 through about 2000, oh no, this is just 2008, but from 2007 through 2015, the ice has taken the same trajectory of declining. This is just one season. As you can see, Siberia and Canada and Alaska are green, the tundra is green, and during the summer, the ice is melting. Well, this is happening over 20 years. It has gone from a huge extent to what it is now, which is even less what you see here. This happens to be September 2008. September of 2020 is about half of that size. The ice is much thinner and younger, and it's disappearing very quickly. So this is 78. The sun reflects off of the snow. It's called albedo. I'm putting rubber duckies up here. I used to have Santa Clauses, but I was suggested by a elementary school teacher to remove Santa Claus, and because the next slide is going to tell you why. We don't want to have Santa Claus drowning in water. Rubber duckies can survive, but that's what it looks like from 1978, pardon me. 1978 to, come on, 2007. So that's 30 years roughly. And of course, there's less albedo on blue water. A blue water event is not good in the Arctic. That's our natural air conditioner. So the canary in the coal mine are not these penguins, but the ice in the background. That ice in the background is an ice shelf in Antarctica, on the western peninsula of Antarctica. Those cliffs are 70 feet tall, what you see above the water. What's below water is 10 times that. The ice, when you put an ice cube in a cup of water, you only see the top 10% of it. Those ice shelves go down 700 feet. Well, from top to bottom, 700 feet. You're just looking at the top 10%. Of course, the penguins are important too, but they're not the canaries. That's 70 feet. What's happening is the water that melts is going down under the ice. This is Antarctica, and it's lubricating the ice sheet so that the glaciers slip and slide. I haven't done this slideshow for a while, so I can't remember how many I have to click this button to get it to go. Well, there was a movie that was supposed to come in. So this is the broken ice coming off of the land and floating on the ocean, in the Southern Ocean, off of Antarctica. you'll see an image of the shadow of the airplane. That's 70 feet that you're looking at. That ice sheet that's on its side, you're seeing the full 700 feet and the top 70 feet at the top for a matter of scale. So in the North Pole, the habitat of the seals and the polar bears and the walruses are disappearing. The walruses are coming on shore, which everybody's aware of. But can you imagine what's worse than that? What's worse is the tundra is melting. It's the thawing of the tundra. This is the concern. There's gigatons of methane stored as methane clathrate in the tundra. And as the tundra is melting, it's releasing that methane. There's an area, I think it's 10 million square miles off of Siberia. It's the size of Texas and California and Washington, one other, Pennsylvania. That area is a very shallow sea, and the methane is coming off the bottom of the ocean. This happens to be the tundra. There's some 7,000 of these methane bubbles that it basically explode unexpectedly, and the methane just, it's like a volcano. It just explodes and blows the tundra away. The tundra basically is organic material that's been accumulated over millions and millions of years. When the North Pole was a tropical climate when the Earth was rotated, it was a tropical climate, and all that vegetation grew and was sequestered and became peat, and now it's basically turned into tundra and it's under the ocean. So the hydrates are the bottom layer there. The hydrates are stable under pressure and temperature. The permafrost holds them in place. And you can see the bubbles coming out in both the lakes on the land as well as from the ocean. This happens to be a lake. You can see the bubbles. Beautiful pictures, but they're very dangerous. This is Greenland. The water is melting off of Greenland at a rate of about 1 million, get this, 1 million tons per minute. 1 million tons per minute. If you saw an Inconvenient Truth, Al Gore mentions 50 cubic miles. 50 cubic miles, that's a 50 miles by 50 miles by 50 miles cube of ice is melting per year off of Greenland. If you work the numbers, that's 1 million tons per minute, 1 million tons per minute. And there's several pictures I like here. It's beautiful water. The water is just pouring off of Greenland, going down to the ocean. And the calving of the icebergs, this is not just a calf, this is a bull, this is huge. And again, you're looking at the top 10% of the iceberg. They basically are coming off of the land and they're coming into the ocean. That's what's causing global warming, that's what's causing sea level rise. I have 10 minutes left. I'm not going to make it all the way through. So anyway, the ice, as you can see, comes off the land and goes into the water. So Al Gore, coming back to his presentation, I'm going to try to finish this up in the next 10 minutes, goes through the typical slides, which he's developed to very carefully educate about what's happening in the science. And it's very well documented, and you've probably seen these images. The temperature's rising, the CO2 is rising, the last 20 years of temperatures have been the hottest on record. All of these beautiful slides that just are gloom and doom. This is Australia, heat waves, fires, Africa, Europe, people dying, highest temperatures on record in Siberia. So I'm not going to go through all these slides, but I want to get down to the very last couple of slides. This is the ocean temperature, abnormally high. It's bleaching it's killing the fisheries and bleaching the reefs, the coral reefs. Beautiful images. If you would like to see this presentation, send me an email and I'll go through it with you. very carefully, but I want to get to I really don't want to talk about the gloom and doom. I want to talk about the hope. What I started out talking about was this is Bangladesh. They're going to be underwater. Sea level rise is going to happen relentlessly no matter what we do. I've been working with a group on, it's a long story, but annihilating methane from the atmosphere using a natural chemical um, reaction from the sun. It's called a photocatalytic reaction, which eliminates methane. But no matter what we do to draw down CO2, the sea levels are going to continue to rise. Bangladesh, underwater. People underwater. Where are they going to go? Shanghai, Miami, the small islands in the Pacific and the Indian Oceans. They're all going to have to leave and go somewhere. Venice, Holland, precipitation. These are beautiful pictures, but it's all gloom and doom. Where are the people that live here going to go? Not talk about the dollars spent on replacing all of this. The investment lost from catastrophic events is billions and billions and trillions of dollars. You can see there's some places you probably know. I don't know some of those places. Midwest floods, India, China, Africa. We're not going to talk about this. This is a detail of science. We're not going to talk about that. Come on. Groundwater, drought, water, fires. Everybody knows about the fires. California, Arizona, Colorado, Washington, Oregon, Australia, Brazil, the Amazon's on fire. Greece, who heard of, now we're coming down. Okay, here we go. The ice, this is Greenland. This is the two slides that Al shows about Greenland. The ice, like I mentioned, is losing 50 cubic miles of ice every year, 1 million tons per minute. That's a lake after the ice is gone. That decline is what we're talking about. We're going to lose the ice on Greenland. That is going to cause the sea level to rise. There's nothing we can do to stop it. Antarctica, ice loss off of Antarctica. Cities at risk: Calcutta, Mumbai, Miami. The amount of money invested in these places. Miami, this is money that's at risk. New York, Bangkok, Hong Kong, Tokyo. So that's all I'm going to show of Al's slides. It goes on and on. He's got another 50 slides. What's love got to do with it? What's ice got to do with it? Well, love is a verb. And what can you do? Do what makes your heart sing. What I suggest you do is spread the word about Greenland ice, spread the word about the Arctic, Siberia, methane clathrate bubbles, methane drawdown, CO2 drawdown, and buy this book. I'm going to switch this over and show you the book, but it's called A Farewell to Ice by Peter Wadhams. And this is newly published. Now I got to get back to me. I'm going to stop sharing. So this is the book. I recommend everybody buy that book. There's a lot of shine on that book. This is an amazing story, and I suggest you read it and understand it. And don't talk about emissions alone. Reducing emissions is important, of course. But we've got to draw down CO2 and we've got to draw down methane. Methane concentration has increased by a factor of 2. CO2 is increased by a factor of 50%. CH4 or methane is 120 times more strong, more powerful than CO2 in terms of global warming. So methane needs to be the conversation. We need to draw down methane in addition to drawing down CO2, and it needs to be at gigaton scale, gigatons per year. So I appreciate your tuning in, and I think I've used all my time now. So I'll be showing this every hour for the next 4 or 5 hours during the day. So I only wanted to do it once. Okay, thanks a lot.